And I want to welcome all our members today evening. This is our first CME webinar of the season. And so we just started the new leadership on July 4th. So we are all new team. And we have many activities planned around the year. So we already finished 1 year. Can't believe that 1 year passed so quickly. So we have 11 months left for this team to work. So every month, pretty much since COVID started, we have been doing some CME webinars and financial webinars and some sponsored webinars. This year, so I have introduced another on the public health policies. So we want to learn more about public health policies and what are the issues we are going through right now in the healthcare. And so it's much needed for us to be educated on the health issues. So that's another thing we will be starting next month onwards from September. And apart from these webinars, API does a lot of other activities around the year. We do a couple of travel, CME travels for the family and members. So we just finished one trip to Tanzania, which was an amazing trip with a very small group because of COVID. Hardly less than 50 traveled, and everyone did very well with all the precautions we took for COVID, wearing masks and sanitizers and all. So luckily we all survived. And we have another trip coming up in September 4th to 12th. Same thing, same trip again, small group to Tanzania too, because a lot of people were asking for another trip. And then in January, we will be going to India for a global health summit. That's one trip we always do every year, which is going to be January 5th to 7th in Hyderabad. Hopefully COVID will be under control, but we just started planning. And then summer is the most exciting finale event for us, the annual convention, which is going to be in San Antonio, Texas. That's my hometown. And today's session is our speaker of the evening is Dr. Lukina Karkanis. She's an allergy immunologist from my hometown, San Antonio, and my neighbor also. That was very interesting to get introduced to her. I haven't met her physically at all till now. And let me introduce our CME chair, Dr. Amit Chakravarti. And also the moderator of the evening will be Dr. Saraswati Mupana from Boston. And let us get started. Dr. Amit, it's all yours now. Unmute yourself.
Thank you so much, and thank you very much for joining this first CME meeting of this year. Thank you, Anupama, for giving me this honor for being the CME chair this year. I am a practicing urologist in Missouri, and in addition to that, a faculty of two medical college, adjunct faculty, do some phase 3 research, phase 3, phase 4 research, been proctor for several device manufacturers around the world, and have actually done the urology part of the CME at several global health summits and API conferences. And I'm glad to be the CME chair. We have got very exciting CMEs going on. We expect to give at least 50 to 60 CMEs this year, which is such a great thing to have, because and we'll try to I'll just explain to you about what we're going to do a little bit more at the end of the talk. But right now, it gives me great pleasure to introduce to you Dr. Lukina Karkanis. She is allergist, a diplomat of the American Board of Allergy and Immunology. She joined Allergy San Antonio in 2014. She is board certified in internal medicine and allergy and immunology. She did her medical degree with honors from Seth Medical College and KEM Hospital in Mumbai, India. She engaged in research activities at University of Pittsburgh, after which she completed internship and residency in internal medicine at St. Luke's Roosevelt Hospital Center and Columbia University in New York, and her fellowship in allergy and immunology at Washington University School of Medicine and Barnes Jewish School of Medicine, just down the road from us at St. Louis, Missouri. She's an active participant in national allergy meetings and has presented multiple reports. She's an active member of the allergy immunology uh, American Academy of Allergy, Texas Medical Association, amongst various other things. She works with adult and pediatric patients and to treat allergies and asthma. She's also a sub-investigator on several studies in the Allergy and Asthma Research Center and keeps abreast of the latest developments of the field. In her spare time, she enjoys art, literature, culinary experimentation, and spending time with her family. So that's an amazing bio, Dr. Kakanis. And we are honored for you to have to be our Sachin Tendulkar to open the this year's CME conferences. Let me also have the pleasure of introducing Saraswati Mupana. She is a very well-known figure in API, very active in API activities. She practices internal medicine and pulmonary critical care, sleep medicine in Boston, Massachusetts, and uh, she has affiliated with Beth Israel Lee Health and Tufts Medical Center in Boston. She was a past president of the Indian Medical Association of New England, 2019. She's a co-chair of Women's Forum and a member of our CME committee. She's very much into community service and believes in giving back and interested in sharing knowledge and learning, and is a major moderator force in ATMA, which is Tamil Association of North America, COVID-19 Tamil Task Team. So without further ado, we will like to get started. I would like Dr. Karkhanis and Dr. Mopana to take the stage and proceed. Thank you. Dr. Mopana, please unmute yourself. Dr. Karkhanis also. You unmute yourself, Dr. Mopana.
Vijaya, can you unmute Saraswati?
Yes.
Right, good.
Thank you. Yeah. Good evening, everybody. Thank you, Api. Thank you, Dr. Gotimukala and Dr. Chakravarti, for first of all for giving me this opportunity. I feel really humbled, and I'd like to thank Dr. Karkanis as well for being a speaker today. She's going to talk, we have several questions regarding COVID variants, and the Delta virus, what is going on. And she's going to update us mainly on the COVID-19 variants, its clinical effects, and also regarding the vaccine. The way this session is going to work is for 30 or 40 minutes. She's going to give a presentation, and that's going to be followed by question and answers. If anybody have any questions, please feel free to type them in the chat box. We will all have an opportunity to ask her questions and pick a brain. And after that, then it'll be Dr. Chakravarti and Dr. Anupama will give the closing statements. So with no further delay, I feel so proud that we started on time, and it's 8:03, and here we are on the Eastern Standard Time. Here we are starting the presentation. Dr. Karkanis, the floor is all yours. You're muted as well, I think. We can't hear you.
Okay, are you able to hear me now?
Yes.
Okay, and then I'm going to share my screen, and hopefully you can see the slides.
Yes, we can see the slides. Yeah.
Would you be able to put it on the slideshow? Perfect.
Yes.
Thank you.
Okay, let's see. So I thought it would be nice to give an update on COVID-19 variants today. I'm very thankful to Api and to Dr. Goti Bukula, who, yes, we need to meet up. We live right down the street from each other. Dr. Chakrabarti, for giving me the opportunity to connect with everybody here. It's great to see so many people here logged on, and I look forward to chatting with all of you. And I chatted with Dr. Saras yesterday, and it was a extremely interesting chat as well. During the presentation, I don't think I will be able to see the chat box, so we can go through the questions in the end. Okay, so I don't have any relevant financial relationships to disclose. I know this is a CME talk, and the main learning objectives that we can do in hopefully a fun and interesting way today are to look at the new COVID-19 variants, what have been their clinical effects on the pandemic, and what has been the vaccine impact on the variants and the impact of the variants on the vaccine efficacy. So both ways. So, a little bit of background. So, the COVID 19 pandemic or the coronavirus pandemic is an ongoing pandemic of coronavirus disease 2019, which is COVID 19, and it's caused by the virus called severe acute respiratory syndrome coronavirus 2. So, SARS CoV 2 is the name of the causative organism. It was first identified in December 2019 in Wuhan, China, and the WHO declared it a pandemic in March 2020. So, we've been living in a pandemic for almost a year and a half now. What has been the impact? So as of August 10, there are more than 204 million cases worldwide of COVID-19, about 36 million in the US alone. And US is one of the hardest hit countries. I'm not sure if that is because we report so robustly, but our numbers are pretty high. There have been more than 4.3 million deaths worldwide, of which over 600,000 again are in the US alone, attributed to COVID-19. And this pandemic has caused the biggest global social and economic disruption, including the largest global recession since the Great Depression. And we keep trying to come out of it, but there are always challenges when you're faced with a virus like this. A quick update on the structure of the virus itself. So SARS-CoV-2, it comes from the family of the coronaviridae viruses. These are enveloped, single-stranded RNA viruses. So their genome is coded into RNA, no DNA. The SARS-CoV-2 RNA is about 30,000 bases in length, and the viral particle, the virion, is about 50 to 200 nanometers in diameter. So if you remember, 1 millimeter is 1 million nanometers. So extremely small virions. And there are four main proteins. This is a pictographical representation, but the big red triangular looking spikes that you see here, those represent the spike protein. And the spike protein is of interest to us because this is the target of all the vaccines currently approved for COVID. And this is what the virus uses to anchor onto the host cell surface and infect the cell. So those are the spike proteins. Then there are envelope proteins on that gray kind of envelope in this picture. Membrane proteins, which are the small yellow and orange dots there. And then inside the membrane, you can't see it in the picture here, would be the nucleocapsid proteins which surround the actual RNA of the virus. And a quick kind of revision on what exactly does SARS-CoV-2 do to our cells, right? So you can see that the viral particles, once they enter mostly through our nasopharyngeal passages, the spike protein uses itself as an anchor to latch on to certain receptors. One of them we know is the ACE2 receptor present already in our body. Once the spike protein latches onto this receptor, the virion is then able to fuse and enter the cell membrane. And then all the genome and the proteins get released. Now, this is a live infection we are talking about. So obviously, the RNA is going to start replicating, and it's going to start hijacking our cellular machinery to make its own viral protein. So that cell is now going to start making SARS-CoV-2 protein. So it will make more SARS-CoV-2 RNA, more spike protein, more envelope protein, more membrane proteins. All of these in certain organelles like our endoplasmic reticulum and our Golgi apparatus will get assembled into new virions, which will then go to the surface and be released and go on to the neighboring cell and infect it, and so on and so forth. So this is kind of how viral infections happen. All viruses typically hijack the host's cell machinery to manufacture their own proteins and replicate. And this is a pictographical representation of what's going on with COVID-19 cases right now in the United States. You can see that the majority of states are orange or red, and orange is about 10 to 24 daily new cases per 100,000, and red is more than 25 daily new cases per 100,000 people. Most of us are orange or red. There are very few yellows left and extremely few greens left. So this third wave, as we are calling it, has spread like wildfire in the US, as it did in the other countries before us where it went. Almost every state in the US now is reporting Delta variant cases. And this is a graph showing nationalized numbers for weekly COVID-19 hospitalization trends. So you can see in September, last year, they were down. The bottom part, the teal color, is non-COVID ICU beds. The orange part is COVID ICU beds, and the gray part is unoccupied ICU beds. And you can see right around January, when we had that big second spike, a lot of the ICU beds were going to COVID patients. And then it got better in May. And now in July and the first week of August, increasing number of ICU beds are going to COVID-19 patients again. Many big medical centers across the country, including the Texas Medical Center in Houston, are running out of pediatric ICU beds and adult ICU beds. And similar to what happened with the initial wave, there are many big hospitals preparing to set up tents and trying to use their garages essentially to get more bed space. So what we thought was behind us is not really behind us. We are facing an onslaught again, and the predictions are that this might actually be worse in terms of hospitalization numbers than the earlier two. And we will look at why we think it will be worse. So what are COVID-19 variants of concern, right? So you had the initial COVID-19 virus that got genotyped, and we found out what its genome was. And then like any virus, it started mutating because there is survival pressure. It's a living organism and it's trying to survive. And so there are going to be mutations happening. So there are many different systems used to name viruses that are mutating. And the WHO has decided to adapt just an alphabetical system. So like we do for our hurricanes and things like that, they have decided we will start with alpha. Hopefully we will not reach all the way to zeta, but right now we are at delta. So there is also a system called the Pango lineages, which depends on a software called Pangolin. That's why it's called Pango lineages. This was what we were using last year. So we were calling it the B.1.617.2 variant. And then it just became too cumbersome to call it that. So now it's alpha, beta, gamma, delta kind of a thing. There is another system called the GISAID clade system. There's a next strain clade system. But overall, the consensus should be that these variants of concern, and by variants of concern, we mean that there is a mutation that is going to cause a pathophysiological change in the virus. So either in infectivity or in virulence or in severity of disease. And there has been enough spread in the worldwide community to make it of concern. So these are the variants of concern. There are probably hundreds of other variants out there, but these are the main variants of concern. And overall, all the authorities, including the WHO, are watching very closely for the spike protein mutation specifically. So to give you a rough idea, the spike protein is about 1,500 peptides. So it's a pretty big protein. So one would think that, 4, 5 peptide, 10 peptide mutations should not really do much. It's kind of like, changing the decoration on your Christmas tree. The immune system should still be able to recognize it's a Christmas tree. It's a spike protein to COVID-19 and should still be able to mount a response because you just changed a few things here and there. But since this is the target for our vaccines, and this is the main kind of a protein that predicts the ability of the virus to infect the host, the spike protein mutations are being monitored very, very closely. The worry is that will there ever be so many mutations that we will not have much protection at all from previous exposure to spike protein. It's unlikely to happen very quickly because if it mutates that much, maybe the spike protein will lose its functionality as well. So there will be some kind of natural control over the spike protein mutations. And then we can trace back where these mutations were earliest documented. So the Delta variant was first documented in India in October. And this is what caused the massive, massive wave in April, May, and June in India. And now India seems to have almost burnt out, though they're still reporting pretty high numbers. And then there's a date when each one was designated as a variant of interest and then a variant of concern. So that depends on global spread and the effect on local and global health measures, basically. And this is from GISAID, which stands for Global Initiative to Share all influenza data. But right now they're also sharing, obviously, COVID-19 data. So this is the share of Delta among sequence samples submitted to GISAID in the past 4 weeks. So this is just past 4 weeks. And you can see that the US is pretty high. We had a pretty high share of Delta amongst all the samples that were submitted to GISAID. More than 80, about 80% or higher of our submitted samples are sequencing out to be Delta now. We are not sequencing every patient, obviously, so this is pretty good indicator that this is the main variant spreading right now. India seems to have burnt out. It's going lower to maybe 60% or 40%. There are several countries that don't report. Those are the ones in gray. And then there are other countries that are at 20% or so. But you can see that almost every country that reports has Delta now. So Delta has spread worldwide. And these are the number of Delta variant cases. So the actual cases that have been sequenced and attributed to Delta in the past 4 weeks, and then cumulative to date. And UK is leading. And I believe India is not up here because India has not been robustly sequencing or at least reporting their sequencing data. It's been a struggle for public health authorities to figure out how to do this in a way that resources will be available to them. So UK leads right now with just in the past 4 weeks, they had almost 60,000 Delta cases. US is starting to creep up. We had 16,000 in the past 4 weeks alone. So what do we worry about with the Delta variant, right? It's thought to be almost twice as contagious. So 40 to 60% more contagious compared to the Alpha variant, which was the original one in 2020. And significantly more viral particles have been found in the airways of patients infected with the Delta variant. So not only does it spread quicker, so you may not really need to be in close contact for the 15 to 20 minutes like we were originally thinking last year, but it also replicates much more and the viral loads are higher in patients with the Delta variant infection. It is being thought that this might cause more severe illness in unvaccinated persons than the Alpha variant, and we are seeing the skewing of the disease towards younger people this time. The risk of transmission is also greater amongst unvaccinated people. And that is why we struggle with our unvaccinated populations, because they may get sick more, they may spread it more, and even if they don't get sick severely, they may spread it to some unfortunate person with comorbidities who is not able to survive. Vaccinated people appear to be infectious for a shorter time, even with the Delta variant. So the vaccines are still having a significant impact. You have to have gotten both doses. So if you're getting a mRNA vaccine, one dose is not really doing much against this Delta variant in the small numbers that were studied, but 2 doses seem to be pretty robust. Maybe not as robust as the Alpha variant for which the mRNA vaccine was designed, but still pretty robust, better than our influenza vaccine by at least 1.5 times. And like I was mentioning, hospitalizations have skewed younger. So either the older people are just were scared and all got vaccinated and are still taking precautions, and the younger population is not. So they have a double whammy. They choose not to get vaccinated and they're not taking precautions, or they just have higher viral loads this time. So hospitalizations have skewed younger. And the symptoms, they are not necessarily always more severe, but there are maybe some minor differences. Now, this is not 100%, so this is not like gospel, but fever, headache, sore throat, and runny nose seem to be more common. So it kind of seems to almost be like your average URI or a head cold, essentially, as your patients will tell you. But the severe cough, the severe pulmonary symptoms, and the loss of smell may be less common this time around. We'll probably still see it, but it may not be as predominant this time around. And everybody's worried that more children are falling sick. And why is that? There does not seem to be like a pathological reason. It's just that more children are falling sick because more are being infected. So since it's almost twice as contagious and has significantly higher viral loads, you can see that instead of 100 people getting it from one person and then maybe one child falling severely sick, now 5,000 people will get it from that one person, and you're going to have 50 children falling severely sick, and the numbers are going to look like children are getting more severely affected. And this is a good graph. I think I have a picture, I have a screenshot on my phone that I show people who ask me about vaccines. This might be a good one for you to keep on hand to show people, to try and convince people to get the vaccine. So these are nationalized estimates, and these are the weekly COVID-19 incidence, hospitalization, and death. And you can see the blue bars are vaccinated, the green bars are unvaccinated. And it's dramatic how much of a difference there is in infection, hospitalization, and death. There is an 8-fold reduction in infection alone. So your 8-fold reduction, 8 times less likely to even catch it. If you catch it, you will be infectious for a less amount of time and you will be sick less. So you will spread it less and you will suffer less. 25-fold reduction in hospitalization and 25-fold reduction in death if you're vaccinated versus unvaccinated. And this is across the nation. It's estimates, but it's across the nation. It's not split by age. It's everybody overall. So, so you have to really impress on people who may still be hesitant that, look, you are really taking a chance. You're playing Russian roulette here with a very dangerous bullet by choosing to stay unvaccinated, because this variant may make you really sick and you may spread it to thousands of people. So what are the vaccine effects? Nationally, as of July 22, 2021 in the US, 97% of patients hospitalized with COVID-19 are unvaccinated. So again, moral of the story, the vaccine is going to protect you from getting hospitalized. Even if you don't stay completely protected and avoid catching the infection, you're going to get a head cold, which is, you have to quarantine, make sure you don't pass it on to immunocompromised people, but you will suffer less, you will be less infectious. And then they actually looked at vaccine effectiveness with the Pfizer vaccine and the Astrazeneca vaccine. And after 2 doses, either Pfizer or Astrazeneca, if you compare the Delta with the Alpha, which was the original, there was still robust protection. It did drop a little bit, but with the Pfizer, it dropped to 88% versus 94%. So still very good protection. If you remember, our flu vaccine is only 50% effective. So 88% is still pretty good. And that is why we are seeing those dramatic differences in incidence, hospitalization, and death with the vaccinated, because 2 doses of Pfizer and Moderna, though it was not studied in this study, it has kind of gone with Pfizer so closely in terms of all efficacy and safety data. I would think there would not be any reason to have a big difference. So Moderna is probably, if you study, also going to have similar numbers. AstraZeneca was 67% effective against Delta versus 74-75% with the Alpha. So AstraZeneca, the adenovirus vector vaccine, overall efficacy is lower than mRNA vaccines, but still better than nothing, better than staying unvaccinated. So people who don't have access to mRNA vaccines, especially outside the US, have access to AstraZeneca vaccine, have access to some other vaccine. Anything is better than nothing at this point, really. And then as of July 22, there were 65,000 breakthrough cases in the US amongst the 160 million who were fully vaccinated. So only about 0.04% of breakthrough cases. And these are cases, these are not severe cases, these are not hospitalizations or deaths, these are cases across the board. And so very low numbers, very low numbers. The vaccine is keeping people from catching infections, spreading it, keeping them from suffering, basically. Okay, so everybody should get and encourage people to get the vaccine. The majority of patients out there are not going to be talking to an immunologist, right? They're going to be talking to their own doctors, their primary care doctors, their pulmonologists, their cardiologists, their all their specialists, their urologists, their pediatricians, their family practice doctors. And so these are kind of good numbers for all of us to keep in mind when we are talking to patients who are vaccine hesitant, or we're talking to patients who have gotten the vaccine but are now wondering what's going to happen. So this data basically backs up the theory that the vaccine is pretty effective. The mRNA vaccine was a jackpot. It really was for us. And what prevention strategies should we be adopting? So the CDC is saying now that given what we know about the Delta variant, vaccine effectiveness, and current vaccine coverage, we need layered prevention strategies. So just like if you think back to those of us who've been on, QI committees and patient safety committees, we talk about the Swiss cheese model where you put several layers. So if there's a hole in one layer in one particular spot, another layer will hopefully not have a hole in the same spot, it will cover it. And so a layered prevention strategy. So we need to encourage vaccination, and we need to have other layers like wearing masks, minimizing indoor gatherings, stressing social distancing as much as possible. All of it is going to be needed. There is not a one and done solution yet to this pandemic. Maybe one day with modern medicine, but not yet. We still need the layered strategy. You need to do everything. Yes, the vaccine is a big tool in our arsenal, but we still need to stay away from sick people, stay away from people who we don't live with and don't work with, avoid large indoor gatherings, wear masks. And then the American Academy of Pediatrics does strongly recommend in-person learning. And I think most doctors, most parents have realized after about a year of homeschooling or hybrid schooling and things like that, the value of in-person learning. But the American Academy of Pediatrics does urge all who are eligible to be vaccinated to get vaccinated against COVID-19. So everybody age 12 and above in this country, as of this moment, is eligible, and there is plenty of vaccine available. There is really no excuse to stay unvaccinated. Everyone older than 2 should wear masks in schools. There will be exceptions for children with special needs and things like that. But these are few and far in between. So somebody who really is physically handicapped and cannot independently safely put on or take off a mask, or a child who's on the spectrum and is unlikely to cooperate and be able to put on or take off a mask, pretty much those are the only 2 true exceptions to the mask rule. The AAP does recommend everyone else practice and wear a mask, regardless of vaccination status. So in contrary to what the CDC had announced, where vaccinated people getting together with vaccinated people in small groups indoors don't need to wear masks, now we are saying no. In schools, you cannot really go around checking who's vaccinated, who's not. Half of the school population is unvaccinated because they are less than 12 years of age. So everybody, regardless of vaccination status, wear a mask. And the AAP does continue to stress building ventilation, some sort of testing strategy, quarantine strategies, and cleaning and disinfection. And the schools have been unfortunately left to figure this out on their own. Each school district is kind of doing their own thing. Many of them are going back to what they did last year, if the local authorities allow them to do that. There has been a lot of debate. Unfortunately, it's become a political topic. But as far as possible, the medical community, I think, should stand with the AAP in urging all of these precautions. And I think we can go to the Q&A session. So, when patients ask me, should I get the vaccine? This is the question I ask them, how would you rather face an angry bear? Because if a bear is going to attack you, it's going to attack you. So COVID-19 is like a bear. It's coming for all of us. None of us are monks. We cannot stay in a bubble forever. We have to go about, make a living, support our family, be productive members of society. Our children need their education and all their activities. Do you want to face the angry bear with protection? So with some degree of vaccine protection, or unarmed? We don't wait for war to break out to start building a military, right? You build your military, you recruit and train your soldiers in times of peace, when you have the resources to do it. Because if you wait for war to break out, it's too late. And it's the same with our immune system. You recruit and train your immune system in times of peace, when you're not infected, and that's what the vaccine is going to do. If you wait to catch an infection, it's going to be too late, because your soldiers are untrained and they're just going to war, and maybe you will win, but maybe you won't. Maybe you will lose, and the mortality rate doesn't matter. If you die, it's 100% for you. So keeping the long hauler syndrome in mind, studies are showing that 35% of COVID survivors have some degree of long-term health problems. And you don't necessarily have to be somebody who was seriously sick or critically ill when you had the infection. Even people that thought they had very mild infections can, on the other end, end up with long-term side effects. Studies are showing pulmonary imaging changes in lungs of COVID survivors and things like that. So 35% of people have long-term health effects. So this is a very dangerous kind of risk to take. So we need to definitely encourage that our patients, our colleagues, our co-workers protect themselves as much as possible.
Right.
And these are the references, and API has my slides. So if anybody wants a copy, please feel free to send them out to people.
Thank you. Thank you so much, Dr. Lukina. I can tell that you put a lot of time and effort in preparing all these slides. And Anupama was right. She said you're going to set the bar to very high for the CME presentations. And we really appreciate all the time and effort you put into sharing your knowledge on this. There are some questions here. And I know you answered these during your slide presentations, but just for the benefit of the audience, could you just again reiterate? The first question is, are there variants more transmissible but less virulent? That's the first one, in brief.
So yes, the Delta variant specifically, the virulence is not that different. So it's not that it is very severely pathological. It does cause more replication though. So viral load can be very, very high. And so if you get the perfect storm with, a patient with comorbidities, with no vaccine protection that catches the Delta variant, it can be catastrophic. You have to keep in mind that overall it is thought that as viruses mutate and as pandemics progress, it is in the virus's best interests to be more contagious and less virulent, right? Because it wants to spread, it wants more hosts. And if you fall severely sick and die in one day, you are not going to spread the virus to 50,000 people. But if you have mild symptoms and you are going about for 4 or 5 days before you even realize, then you are going to spread it a lot. So a kind of mutation pressures are what cause this increased transmissibility and less virulent.
Right. There's also the R naught, right? The reproductive number. So for alpha, it's actually, if it's 3, for delta, they said it's around 6. So one person can transmit it to more or less 5 or 6 patients, 6 people for the delta variant, compared to the alpha, where the R naught is only around 3. One patient was transmitting to 3 people. So that's something also to keep in mind.
Yes.
And the next question is, how much worried should the fully vaccinated people be of the variants?
So like we talked about, the vaccines work. They work against even this Delta variant. They are very, very good. That does not mean that you give up all your protection. You still have to mask and take care. But I think you can feel reassured if you're vaccinated and you're otherwise healthy, that the vaccine is going to help. It's going to help. It's going to keep you from catching it, going to keep you from suffering, going to keep you from spreading it too much. It's going to help definitely.
Right. And the next one is the booster dose for Pfizer and Moderna. I know there's a lot of controversy regarding this, a lot of unanswered questions still. But anyway, from your experience, is it being said it'll be only for immunocompromised people, or
So
who will be included in that?
nothing like that. There is no definite answer yet from the CDC or from the NIH. Um, we have to keep in mind that we live in a very privileged part of the world. We have so much vaccine, we are throwing away vaccine every day. And there are millions of people worldwide that don't have access to even one dose of the vaccine. So this answer becomes a little complicated, because then do we just re-immunize and re-immunize and re-immunize the well-off countries, or do we share our vaccine with the countries that will otherwise just suffer and suffer? The WHO is against the booster doses as of now. They have officially said, the developed nations should not give out booster doses before they share vaccine with the developing countries. They're estimating they need billions, trillions of dollars worth of resources to be helped to help some of these countries get even 20% vaccine compared to their population.
That is true.
So I think that is why the general feeling seems to be that even if the booster dose is recommended, we will first give it to our immunocompromised people, so that it doesn't look like we are just hoarding our vaccine and our resources all for ourselves. There is a chance, though, that eventually all of us will need a booster, but we don't know yet whether it's going to be the same exact, or whether Pfizer or Moderna can really come up with a Delta variant booster that's more targeted towards the mRNA of the Delta variant. Because, anytime you change something and it goes to the FDA, it has to go through the whole process again. So every time they change something, they have to again prove that it's safe and effective. I also think that before we give tons of booster doses, we will want to vaccinate our children. So we are expecting authorization for hopefully 2 to 11, but at least 5 to 11 to come. They were saying late fall, now they're saying early winter. So somewhere around October is the timeline, but it's not been submitted to the FDA yet for authorization. So that might be another place to first dedicate our resources in terms of vaccine availability before doing widespread third doses for the whole community.
Right. So we had a meeting today in Massachusetts regarding the COVID-19 updates. So they were saying for children less than 12 years, they're looking at January 2022. So that's
maybe
one.
even,
And
yeah.
The second thing is regarding the booster doses. There is also a factor, right? Is the pharma really pushing for the booster? Pharmaceutical company, they want more sales. So are they really pushing for the booster, or is the booster really going to be effective? So nobody knows yet.
Nobody does. And we are the study group now. The people who chose not to get vaccinated are the placebo group, and we are the vaccine arm. And this is the largest study going on nationwide. And data is being collected as to, how many people get infected, how many people get in the ICU, how many people get hospitalized. So yeah, so until we see a big difference in those numbers, where maybe we start seeing vaccinated numbers for hospitalization and ICU and deaths starting to go up, it's probably not going to look like it will support getting a booster dose of this very same variant all over again.
Right. Talking about variants, what about the Lambda? And Dr. Chakrabarti has a question. What about the Epsilon? I think it's Greek letters, one after the other, right?
Yes, yeah. So yeah, we started with Alpha. Right now, the Delta is the main variant of concern. But yes, we are going down the alphabet line. So I don't have any data right now on the Epsilon and the Lambda specifically, but I'm hoping we don't reach Z. I'm hoping we get a handle on this before we reach the last alphabet. But that's That is, it's expected. That's what viruses do. They mutate and they want to survive. So another thing to keep in mind, how vaccination helps, right? Suppose it takes 1 million replication cycles
Right.
to get a mutation that confers a survival advantage on the virus, right? If the majority of your population is vaccinated, then the virus is only going to replicate maybe 10,000 times before the host recovers from the infection. And the other hosts are all vaccinated, and they're also only going to allow the virus to replicate maybe 10,000 times. And so it's going to be hard for that virus to find that one dangerous mutation that's going to confer a survival advantage. It will take longer because it won't reach that 1 million replication cycles and mutations in the same host very quickly. But if the majority of your population is unvaccinated, then millions of replication cycles are going on. And then, the virus is going to get lucky one fine day and find the next mutation. And then it's going to find the next mutation. And whatever confers survival advantage is going to spread in the gene pool. So that is the other advantage of having high levels of vaccination and herd immunity, is that the virus just, it becomes harder and harder for the virus to get lucky, basically.
Right. Right. Regarding the Lambda, it said that it's not going to be as virulent as Delta, but I think we have to wait and see.
Yes, yeah.
It's
Right now,
too
the
early
Delta
for
is
us.
the main one
Yes.
affecting public health measures and modern medicine.
Right. Moving on to the next question, Mr. Ina says, I'm fully vaccinated, but getting an RT-PCR because of his persistent cough, no fever. If it's positive, then what measures he needs to take?
So whether you're vaccinated or not, if you test positive, then the instructions are pretty much the same. You do have to quarantine for 10 days, and then you can get out of quarantine as long as you have been fever free for at least 1 day without any fever reducing medication, which you don't have a fever to begin with, so it should not be a problem. And you see some improvement in other symptoms. We don't expect your cough to be completely gone. We don't expect your anosmia to be completely relieved, but you have to see some improvement in other symptoms. So whether you're vaccinated or not, if you test positive, it's the same. It's the same precautions for everybody.
Right. So today in my pulmonary clinic, I saw a patient who has known asthma and has been vaccinated. She had COVID in January 2021. And after that, she got repeatedly tested because of work. She works as a CNA, and it's always been negative. She came to me yesterday, she did not come, it's a telemedicine visit. And 2 days ago, she had these symptoms, cough and sputum, thinking that it could be asthma exacerbation. And we got a COVID test. She's positive. She isolated herself in the basement for 10 days, and that's the plan. Her husband and mother, who's 88 years old, they live in the same household. So she's come downstairs to the basement level, and they're also going to get tested. So it is at least 10 days away from work, away from everybody, home isolation. And I did instruct her, in case she has any cough, shortness of breath, any symptoms more than usual, then she should definitely go to the emergency room.
Yeah.
I mean, to get the
Yeah.
treatment. Right.
So yeah, and hopefully if she's vaccinated, it will be mild. The ones that I have seen vaccinated, they're all mild. In San Antonio, right? I'm an allergist, so a lot of these patients think they're just having allergies,
Right.
and they don't even realize that they have COVID, basically. So hopefully it will be the case. Yeah.
Right. Absolutely. And she is morbidly obese as well. So she does have the risk factors also.
Yeah.
And the next question is regarding, I think, Dr. Suresh Kumar. As per the current study from Mayo Clinic about Moderna being more effective than Pfizer, should people with Pfizer take booster dose of Moderna? This is a question which so many of my patients ask. I want to see what your take is on this.
I don't think that they have shown a difference in effectiveness in real life. Sure, in the lab, in the study, you see those differences, 93, 95, 88. Is that going to make a difference in real life is the question. As far as mixing vaccines goes, right, there is no medical reason why one cannot. Because what Pfizer does, what Moderna does, what AstraZeneca does, what Johnson & Johnson does, it causes temporary production of spike protein in your body, right? The vaccine lasts a few hours, a few days. The mRNA, adenoviral vector DNA, it's gone after that. It's destroyed. Our bodies are pretty good at destroying foreign material like vaccines. But what's left is a spike protein that your own cells made, because your cellular machinery was used to make that spike protein, and then the immune response that you mount to that spike protein. So it should not matter how you made that spike protein, whether you made it from an infection, you made it from Moderna, you made it from Pfizer, Johnson and Johnson. It should not matter. But we still do see differences in efficacy. I don't think that there is a way to know this right now. If for example people were to all suddenly require a booster, I would be telling everybody, get whatever you can find the soonest. So if you can find Moderna, take Moderna. If you can find Pfizer, take Pfizer. I don't think there is any biological need to stick to the same vaccine. There should not be any unexpected surprises, because nothing like that has happened so far. There are plenty of people who got non-US approved vaccines. For example, grad students and undergrad students, residents, and people coming from abroad to study here, who were mandated to revaccinate with a US approved vaccine, and they have all done fine. They went and got whatever they could find. After landing in the US, they've done fine. So there is no need particularly to stick to your manufacturer or not stick to your manufacturer. I don't think it will make a difference.
Right. I totally agree with you. Getting vaccinated is the most important thing.
Yes.
And getting both the doses is the most important thing.
Mhm.
I think that's the bottom line. And moving on to the next question, Dr. Manoj Modi. So far, what vaccine promises better protection against the Delta variant in the US and India? I know you've already explained it, but if you can tell in brief. We have lots
So the mRNA vaccines, either of the mRNA vaccines, Pfizer or Moderna, I would say are better than the adenovirus vector vaccines. The study has looked at one mRNA, one adenovirus vector. So it looked at Pfizer and it looked at Astrazeneca. They were both good. The Pfizer was better than AstraZeneca against Delta, but it's also better against Alpha. So that's not unexpected. So if you had a choice, which people in India don't, right? But if you had a choice, then you would go with the mRNA vaccine, I would say. I think it has to do with the biology of the vaccines. The main difference in this efficacy and why mRNA vaccines, the first mRNA vaccines we've ever had, have shown such good efficacy is it's the mRNA platform. It's such a clean platform, and it's so I explain it this way, right? If you have a friend who has like a lot of food allergies and you want to bake them a cake, right? If you're baking it in your kitchen, you're always going to be worried. Did I clean the pan? Did I clean the mixer? Did I clean the oven? Was there egg on it? Was there this? Is my friend going to have a reaction? Versus you can just give your friend the recipe and they can make it in their own kitchen. And their kitchen is obviously going to be well suited to their needs, right? That's what the mRNA vaccines do. They just give our cells the recipe and the blueprint, and our cells make the spike protein. So they probably make it in a way that's best suited for that person's cells to respond, right? Because everybody's a little different.
Right.
As compared to adenovirus vector, it's going in an adenovirus vector, the RNA is going to DNA, the DNA is then going to the nucleus, getting converted to RNA, and then being converted to protein. So there is that extra step. And I think each extra step adds extra things to it. As compared to, say, Covaxin, which is available in India, it's an inactivated vaccine like your flu vaccine, your flu shot, right? They're making actual virions and killing them, chemically inactivating them and injecting people.
Right.
Now, you cannot make virions on like a 3D printer. These are viral particles. They have to be made with cellular machinery. So they're using cell lines. They're using cell lines to make these viral particles. And then no matter how careful you are, how much you purify it, some of that cell's proteins are always going to end up in your vaccine vial, because these are ultra microscopic structures we are talking about. There's not a good way to keep your viral particles stable and intact and kill all the other proteins around it and take them completely away. So I think the mRNA platform just has very little of extra material. because very little is made outside the body. Everything is happening in the host body itself. And then as you keep adding more and more things to it, a vector or cellular proteins from the cell line and things like that, that you, number one, may see side effects to those extra things, and number two, we are seeing decreased efficacy with that.
Right. So we have 5 minutes and we have a ton of questions. So we are going to go through those as quickly as possible. Pregnancy and vaccination, your
Yes.
thoughts? It's like a fun
Um,
round.
Right, yeah, highly recommended. Right now, the American College of Obstetrics and Gynecology and the Maternal Fetal Medicine Association, and I think all the medical community in general should stand behind them. COVID infection, alpha or delta or any variant really, COVID infection in pregnancy can be catastrophic. I mean, the moms end up in the ICU. We have a lot of stillbirths. We have a lot of preterm labor. We have babies ending up in the NICU being born COVID positive. Um, and the vaccine is so safe. It is so safe. It's not even going to go to the placenta. It's not even going to really do anything to the fetus. If anything, if mom mounts a good response, the baby is going to get some of mom's COVID antibodies and is going to be born protected to COVID for the first few months of its life. Um, like we do tetanus boosters and Tdap boosters for moms, so that babies are born protected for the first few months of life. So it's the same thing. Highly recommended. Anybody who is pregnant should definitely get vaccinated. In fact, in many places in the country, pregnancy was considered a high risk condition, and they were actually allowed to get vaccinated in December and January, along with healthcare workers and the very elderly and the very high risk patients. Pregnancy was actually listed as one of those. And so they were actually letting them get it ahead of everyone else, because that's how dangerous the infection can be.
Right. And Dr. Govila has a question regarding infants at risk for Lambda variant. And I think we discussed about the Lambda, not much is known as this. And she also has another question. Can we recognize what variant has been, what is the cause of the variant? Which variant is it? Is it Delta or is it Lambda?
So you need to type the sample. You need to send a sample for genotyping to know what variant it is. And that's not easily commercially available even in the US now. The kind of the local and state authorities have their own protocols in place, and certain numbers, certain percentages of positive samples are always sent for typing. And then certain cases that are sent to them for review may get typed as well. But yeah, you have to genotype the sample basically. So this is not done all the time.
So, and the booster doses, will they include the Delta variant? I think that you answered already.
Yeah, we are waiting to see. We don't know if Pfizer or Moderna can do that quickly enough, and if the FDA will authorize it. Just so we know, Pfizer and Moderna, I believe, have both filed for full approval. Right now, they have EUA, emergency use authorization, but they have filed for full approval with the FDA. And that typically FDA wants more time. It wants at least 2 years of data, and the vaccines haven't been around for 2 years. So it remains to be seen if the FDA is going to make an exception and grant them full approval. That will make it much easier then to get, approvals for a different age group, a different variant, and things like that.
Right. And Dr. Reddy has a question. Thoughts on booster dose? Okay, to immunocompromised healthcare workers. And I think to the immunocompromised population and healthcare workers when it comes.
Yes, definitely. I think we'll go down the same kind of algorithm we did when the first doses came out.
Okay. And Dr. Patel has a question. Is there any harm in taking the booster dose, knowing all what who states and others, but is there any harm for the booster? The basic question, harm for booster.
So the only harm really is that everything carries a small risk of side effects. So even Tylenol that we take or anything really. So you may have some side effects because this is now your third dose or your second dose if you took J&J, but for most of us it will be our third dose. So with every dose you take, you may have some mild or moderate side effects. That's the only risk really. Otherwise, there's not a risk right now because the vaccine is so readily available. So it's not like you're taking a dose away from somebody because that open vial is ending up in the trash at the end of the day with 1 or 2 doses left in it. So yeah, the main thing to keep in mind is there's always risk of small risk, but not zero, of some mild side effects.
So just on this note, actually, patients who are, if they develop any side effect for the vaccination, there's a website on CDC, there's a form where you can report the adverse effects. And it's really, I would highly encourage if anybody develops skin rashes. A couple of my patients developed herpes, they developed shingles and they had facial palsy. So it's really important to report it through that form for the adverse effects. So we can share the knowledge and see what all adverse effects are happening. And but that shouldn't cause a fear to get the vaccine. Please get vaccinated. So
Thank
the
you.
And
next,
in fact, the NIH has also now started a study for patients that had true severe anaphylaxis to the first dose of COVID vaccine.
yes,
They are going to try and figure out a way to give even those people the second dose.
yes.
So the mandate in general for humanity seems to be that we need to immunize people fully as much as possible. So yeah, there are very few true contraindications to the COVID-19 vaccine. And I strongly believe that if somebody wants a contraindication, they should see an immunologist before they are given that kind of free pass. Because, I mean, this is not a question of personal belief anymore. It's literally affecting the human race worldwide. So,
So Dr. Lukina, I think there's only 4 more minutes left, but we're going to conclude the session. You said it very right yesterday when I asked you, how do you want the presentation to go? You said it has to be enjoyable and educative. I
yeah.
think it had both the pointers. It was both enjoyable and educative. We wanted to ask the audience if they want to have a session two. I'm sorry, there have been so many questions. We're not able to accommodate this time because of lack of time. But if all of you want, we could do a session two on the same thing, updates on COVID, like a part two. I think we can do that. So we'll be able to answer your questions as well. I leave it to Dr. Chakrabarti and Anupama. Thank you so much, Dr. Lukina. We see your enthusiasm and thank you so much. We really appreciate that time and energy. Thank you.
Yes. Thank you for the opportunity to connect with all of you. Thank you.
Thank you so much, Dr. Lakina and Saras, Dr. Mapana. Thank you very much. Anupama, over to you before I conclude the session.
Thank you, Lukina. That was a very, very informative session. I think we all needed that to see where we are. It's such a very good, informative talk. And thank you, Amit, and thank you, Saraswati. Great moderation. I myself have one question for you. You being an immunologist, so we have seen minor to major anaphylactic or allergic reactions to the vaccines. Like, what percentage came to your office for, for any kind of guidance or treatment or future fear of future second dose vaccines? Similarly.
So we did see a significant number, not as many as we should have. I think a lot of patients just got so scared they never came to see the specialist. But I can tell you that I have been able to get people to take the second dose 100% of the times after they've come to me. So a lot of these are pseudo anaphylactic reactions. A lot of these are really vaccine side effects. And it may sound funny, but common sense is not common. So people saying, I was feeling dizzy in the middle of the night. I went to the bathroom and I passed out. Well, isn't it common sense if you're feeling dizzy, don't get up and walk in the middle of the night? But apparently that is not common sense. So simple things like reassurance and being like, you have to drink lots of fluids and you have to keep Tylenol on hand. And if you're feeling dizzy, don't try to walk. Sit up very slowly, stand up very slowly, get somebody to help you, and then they can tolerate the second dose fine, because these are simple measures. So it doesn't do well to completely ignore or downplay their concerns, because everybody's a hero of their own story. So for somebody who passed out, that's a very scary side effect. They don't want it to happen again. So you can't ignore their concerns, but there is a way to kind of weed through it, find out what actually happened, come up with a plan for them to have medications on hand, tell them exactly what to do, what not to do, and and most of them can get the second dose. Everybody who came to me has been able to successfully get the second dose. So I think we just need to be prepared as doctors that we are going to get these questions, and sometimes even simple instructions like drink water, drink fluids, and then they're like, oh, I never realized that. Yes, that is a very big thing. A lot of patients, if they're scared of rashes, I put them on antihistamines, because a week of antihistamines is not going to hurt them. It may help, but a lot of it may be placebo. But if they can get the COVID vaccine, I'm okay with that. So that's why I feel like somebody who really strongly is very scared, send them to a specialist, and we can, most of the times we can figure out a plan for the patient that they feel comfortable with. Sometimes that plan is, get it in my office, because they feel reassured if it's in a doctor's office versus CVS or a Walmart pharmacy. But yeah, most of these patients are able to tolerate the second dose just fine.
Thank you so much. And a few people are getting antibody testing. And for those who are vaccinated, do we really see antibodies or no?
We do. The studies did look at it, because in a study you have to. So in the studies, they looked at it and they saw obviously significant differences in the spike antibody in the vaccine arm versus the placebo arm. They also did T cell studies in the studies, and those are not even available commercially. You can't really order them for patients, but they did see T cell responses in the vaccine arm versus the placebo arm. The problem with testing in real life is that you never know if the right test is being done. So, there are so many tests now for COVID antibodies. It's very hard to get through to the lab and be like, I want specifically spike protein IgG tested, because if they check nucleocapsid IgG and it's negative, that's expected, because there's no nucleocapsid protein being manufactured from the vaccine. So it's unreliable, because I don't know if the labs do the right tests, and then patients get concerned, and then it becomes this vicious cycle of, why did we look, we should not have started. So I think, I don't recommend checking the spike protein antibody routinely. I think we should just trust the vaccine that it does work. Majority of our viral protection is T cell, and we can't even check that.
All right. Thank you. Thank you so much. That was a very, very interesting talk. And let us conclude. And Vijaya, you have can you display the recognition plaque?
Thank you.
Thank you so much, Dr. Lukina Karkanis, for your contributions as our CME speaker today, and welcome you as a member of API Distinguished Speakers Club. It's an honor for us. And this is from me, Dr. Anupama Gotimukula, President API, and from Dr. Amit Chakravarti, Chair CME, and Dr. Saraswati Mupana, moderator today. Today is August 11th, 2021, Oak Brook, Illinois. And the webinar will be on our website. Anyone can hear the talk again and again. It will be on the website tomorrow from our office. And thank you so much, and good evening, everyone.
Thank
And
you.
we should meet.
Thank you so much. Thank
Yes.
you, Dr.
Thank you. And this was an amazing session, as I just now mentioned in the chat box. Great start, and Dr. Lakina, it was amazing, beautiful grasp of your subject, and very, very, explained to us in a very layman terms, so to speak. People who are not allergists, we understood the whole thing very clearly. I thank you very much for all of you attending this initial session. We almost had 200 people on a Wednesday evening, which is a great, great thing. What we are doing going forward, we decided a little bit more attendance we might get if we do it on a Saturday morning, and we have seen that in the past. So from next time onwards, we'll do it on the second Saturday of each month. We're doing it at from 11 a.m. to 1 p.m. Central Standard Time. second Saturday of each month. And we have got a great speaker, which I'm going to announce for tomorrow, next time, because I just got the confirmation this today. Barring any emergencies, we have a very great topic which will resonate across all specialties. Every physician in the United States will like to tune into this, and the topic is troubled waters in safe harbors: how to cope with legal pitfalls in your current medical practice. And the speaker will be none other than our own Dr. Rakesh Chandra, who incidentally is an MD JD. He's a graduate of All India Institute. He's an MD and also an MD JD. He actually practices healthcare law in Illinois. And his son, who is actually also an MD and is following in his footsteps, both have given a talk for me earlier for a subchapter earlier in the past, and they are amazing speakers, and we are great to have them next time, which is will be on September 11th, September 11th at 11 a.m. Central Standard Time. And the link and all the information will be sent to you. And just to make sure that you keep it on your calendar, barring any other reason, for example, suppose a CME tour has come up or global summit has come up or something like that during that time, we will do all our CMEs on Saturday morning, 11 a.m. to 1 p.m.
Thank you. Thank you, Amit. We standardize our CMEs from next month. Yeah. Thanks a lot.
Thank you.
And have a good night.
So much. And we are
Good
also going
night.
to add risk management in the CMEs.
Yes, we're going to add. We're going to add. That's something that what I wanted to add. Also, thank you for reminding me. We're going to also do some topics on risk management, and so that everybody who reapplies for license, we have to have this risk management. We have to have medical documentation. We have to have something regarding opioid use and stuff like that. All those things we have to do these days to get a license renewed. We're going to try to do that as RPCME, which will work both ways. We also have something else in the works, which is a little something which we have in the works of doing a session basically educating people on basic CPR, basic life support, basic and advanced life support, though we won't have live mannequins, but people might like to do, hey, what do I do for this? We might have an ER physician. I know the person, which I've not asked him, who's going to tell you what to do on basic things, bee stings, regular stuff which everybody may be faced at home. So we're going to make these topics more user friendly, more kind of every specialty will enjoy that kind of topics. So I hope we'll have a great year. Thank you very much for you hit a sixer, Lakuna.
Yes, very well. One last question. This Dr. Nisha asking, are these sessions considered as live to count for the live CME? Any idea?
These are live CMEs.
These are live CMEs.
So if someone is attending these